week we had to postpone it due to some technical difficulties, but we got through it. So here we have Ivana and TD from our Delta Lake ecosystem teams, and we are here to answer questions about Delta Lake releases, Delta Lake features, and if you have any questions related to what's going on, and if you don't see any features in our roadmap, you can ask questions about it. A quick recap from the last session. So we had Scott, Venki, and Denny as panelists during last session who provided amazing insights on the connector ecosystem, Presto, Delta, and Trino Delta integrations. We also got a sneak peek of the feature which was going into the Delta Lake 1.2 release, which were column stat generation, data skipping, which is a big boost to read performance. And then we also covered Delta Flink Sync and updates on Delta Flink source. We also covered file compaction feature and improvements to restore the Delta table to earlier snapshots. So we will talk more about it a little bit in this session as well. Also, a few highlights on the future releases were improving the file compaction to capture the partial progress and also adding the Z ordering so that the queries will be faster. So that's a recap. Now I will hand it over to panelists so they can do a quick introduction. So TD, why don't you just say hi and a few words to our community?
Hey everyone, I'm universally called TD, that's my initials. I am a staff software engineer in Databricks. I work with the folks that focus on the Delta Lake OSS project. And my background is I've been involved with the Spark community for the last 12 years. Been working on stream processing in Spark for last close to 10 years now. But my focus now is on the Delta Lake project, and I'm very excited that we just last week released Delta Lake 1.2.0 with a ton of new features that is going to make the Delta Lake users' life a lot more easier with a lot of features just present out of the box. So, Ivana?
Yes, thanks. Thank you. Hey, everyone. I'm Ivana. I'm a data engineer working as a consultant based in Belgium, part of the Delta ecosystem, and actually doing a lot of implementations using Delta at different customers in production systems.
That's awesome.
Sure.
Yeah, you're working on like large scale products, Ivana. So glad to have you as well, and our OG TD here. So that's exciting. So TD, you mentioned that we were working on Delta 1.2 release. What are some of the key features that community should be excited about? I know we talked about performance, we talked about user experience improvements. So few things that you would like to shed light on. Yeah.
Yeah. So I think we can start. Yeah, as you correctly identified, there is performance and there is user experience. So performance-wise, one of the features that was most awaited for a long period of time, and finally we have it in the open source, is the column stats, where the short explanation of that feature is when we write out files into the Delta Lake format, we automatically collect stats for columns, like for each file for the first 32 columns, which is configurable. We keep track that within each file, what is the max and the min values of that column per file. So this is column stats, and we save this as part of our Delta log, which contains all the metadata of what files are present in the Delta table. So we save along with that. And the advantage of that is that when you're actually going to read the table, if your SQL query or your data frame query, it doesn't matter where you're querying from. If your query has like filters, like read only column value equal to 5, something like that, we can use this min-max stats to pretty aggressively eliminate files that cannot possibly contain the rows that you're looking for. So even before, so we completely skip even reading those files whose min max range does not include 5. So that is a lot of data skipping. And depending on your type of query, if you have query that is going to expect it to filter out a lot of files and focus on a few rows, this can help in uh, eliminating a lot of scans out of the box. Now, the tied to this is our future feature optimized Z order. And without going to the details of Z order, what Z order is basically a multi-column spatial distribution curves. What it basically does, to not use fancy terms, it can cluster the data in your table uh, such that the min-max ranges of each column in each file is small, so that when you are looking for a particular value of that column, only few files can contain that value. Most of the files can be eliminated just by doing the basic data skipping on the min-max without even touching and reading those files. So to make this data skipping using column stats even more effective, we are working on Z order data clustering, which hopefully the next release of Spark, next release of Delta, we will be able to make it to that. So that's the performance track of stuff. Then the user experience track of stuff is actually tied to this optimize command I was saying, that we are working on optimize Z order, which is the data layout reorganization for better clustering. But what we released in this is optimize, which is just file compaction. So earlier there wasn't any inbuilt command to make it to do the file compaction. If you are writing out from a streaming query, you often end up with many small files, which can cause read performance to be lower. This command can very easily compact them into 1 GB files, which 1 GB is a very sweet spot, that they are large enough to avoid any small file reading overheads, but not large enough that you're not sacrificing parallelism, etc., for reading those files. So Optimize comes out of the box now. Similarly, another user-facing API is Restore, which if you have accidentally added data into a table that you know is bad or corrupted because some rows has invalid values and stuff, then you can quickly find out which version of the table. You can look at the history that is already, those commands are already there, describe history. You can look at which version of the table has correct data and revert the table, roll back the table, or restore the table back to that version, either by version number or by timestamp, in order to eliminate any changes that you don't want. This is again another very useful feature when you have to fix something that went wrong. So yeah, having all out of this box definitely improves the user experience and stuff.
Thank you, Didi, for giving like highlight of each of the feature. So I think the first feature you mentioned was data skipping. For that, we collect column stats. Can you go go a little bit deeper into what how does it collect information about those column statistics? We are only limited to 32 columns. Is there any limitation on the column names or things like that?
Very good question. So let me break it into two parts. How does it collect, and then limitations on the column names.
Yeah.
How it collects is that, so Delta uses Spark's Parquet writing code path. So Delta just says that just allows Spark to do its Parquet writing. Now Spark has hooks into its Parquet writing code path where you can add your own stats collecting framework and stuff. And so as every row is being written out to Parquet file, that stats collecting framework can inspect the rows and check what is the value of each column in that row. And using that framework, Delta plugs in to collect statistics of the first 32 rows and statistics specifically min, max, null counts and stuff. So it basically nicely hooks into existing APIs already provided by Spark. Now, why first 32 columns? This is to kind of as of now, and this is not a hard rule, all these additional column stats needs to be stored in the Delta logs along with the file names and stuff. So this can add quite a lot of overhead to reading the log. We don't want the log to be unnecessarily huge. So that's why as of now, we are limiting it to the first 32 columns. And so you have to, and 132 is a configurable number. You can expand it if you want. And 2, if you don't want to expand it, but you want your columns to be present in that column set because you're going to frequent filter on that column, you can use alter table to change the column order and put that column within the first 32 columns. So those are 2 things that you can do to make it work. The second question, Vini, is there any restriction on the column names? And that's a very interesting question because that leads to another user-facing feature that I kind of skipped earlier talking about because there are so many, is that we recently added support for renaming columns as well as making each column name support arbitrary characters. Like earlier, we had the limitation that that column names cannot have spaces or Unicode and that kind of stuff because Parquet file format did not allow column names to have those. With 1.2.0, we released that additional feature where the Delta log can maintain a mapping of the actual user visible column name that can contain arbitrary characters to the column name that is actually saved in the Parquet file, which is there's a level of indirection, and which allows us to change, rename columns, drop columns in the future, or have arbitrary characters in the column without being limited by what the Parquet format supports as in their column name and stuff. So this is another user-facing feature that was in demand for a long time, and finally we were able to do that. We added support for column rename. Next release, we'll add support for column drops as well.
So Delta has come really a long way, Vini, right?
It has come a long way.
That's awesome.
Yep.
So with that, there was also one more feature was, if you have Delta offers generated columns, right? So can you talk a little bit about that as well? Like, does Delta Lake collect any statistics around it and how that works? Yeah.
Yes. So again, another feature, man, we are running out of time to talk about all the features we released. So along with the column stats based data skipping, another performance improvement we did is that Delta already had support for generated columns. And for those who are not familiar with generated columns, it's a feature where you can say that the value of column 1 will be always generated by expression on column 2. For example, where this is useful is that let's say you have timestamp in your data, but you want to partition by date. Instead of, so one way to do it is extract the date from the timestamp and do it. But if you do it through generated columns, then the Delta log is actually aware of the relationship between these 2 columns, that a date is always a function over the timestamp. What it allows us to do is the new feature is that whenever you have any filters on top of timestamp column, say I want timestamps to be within this date range, we can automatically generate additional filters on the dependent generated partition column for date, which means that in many places we can take full advantage out of the box of partition pruning and stuff, like dynamic partition pruning, etc. can work with this additional automatically generated filter on partition columns that are also generated columns. So this is all taking advantage of the more information you give us about the relationship between columns, we want to take advantage of that and use mechanisms already in Spark, like partition pruning, etc., or dynamic partition pruning, link them together using these mechanisms, to give you the best performance out of the box.
So TD, you mentioned about this. This is awesome, right? By the way, this generated columns is like a column that is automatically added by Delta Lake, if I'm correct.
Yes.
Right.
Yes.
So what is it that's happening in Delta Lake which allows it to generate that column? Can you give a little bit of mechanics there?
Yes. So the way it works is that when the user is defining the table, defining the schema of the table, the user has to specify that column 1 of type date generated always as some expression, some SQL expression on another column of some timestamp. In this case, in our example, the timestamp column. Now, that dependency, that SQL expression is stored as part of the Delta log. And because of that, it does two things. At write time, whenever it sees the value of the timestamp column, it can automatically generate the value of the generated column, the date column, and write it without the user actually explicitly specifying the date column, which means that from the writer point of view, the writer doesn't need to worry about actually doing that generation themselves. If you just give it the timestamp column, the date column will get automatically generated. It is more foolproof, because otherwise multiple applications writing the same table, computing date differently, etc., that can't happen. And if by any chance some application is misbehaving by computing the date incorrectly, then the generated columns using the same expression will also validate that whether you're trying to write data that is satisfying that expression or not. And if you're not, because some writer is misbehaving, then it will block that write. So it serves two purposes, both as a automatic generation of data as well as a constraint, which is another feature existing in Delta, where you can specify constraints on data that this column value cannot be this or something. So it serves that as a barrier to corrupting the data as well. So that's how it works.
Got it. That's helpful too. You keep adding more features. That's amazing.
Well, this is what we have in Delta, and the way these features are designed is that they work very well with each other using the same underlying concepts, so that ultimately from the user point of view, things just work better out of the box. You cannot corrupt data. If you give it more information like additional constraints, generated columns, there are more features coming along the way. Just try to take advantage of it as much as possible to give better performance out of the box.
That's awesome. So TD, you mentioned about user performance. Now, saying that, I would like to ask a question to Ivana, who implements, Delta in like production as well as scale it in the client's environment. So Ivana, how do you see these features fit into client's environment?
Yeah. Actually, this release has very exciting features, something that people were waiting really, especially on the performance part, on optimize. This is something which was very much needed, especially if you're working with small files, or with, especially in streaming cases where you generate a lot of small files. You have the small file problem, so this solves that perfectly. It's something that was, I think, long awaited, and people using Delta will be very much happy about it. But also, as TD's mentioned from a user experience, there are a lot of features here. The one he mentioned about the column names, I had that problem a lot of times. At clients where, okay, you have some columns or some strange characters that they still wanted to persist them in Delta, but it was not possible before. So I think this is something which is also one of the nice features. But this release has really many features which really have better performance, or bring better performance, and a lot of user experience improvements.
That is so good to hear from you. This is awesome. Like hearing directly from the practitioner like you. This
Yeah,
is great. This validates all the work we have been doing
yeah,
for this. So thank you for those kind words.
yeah. No worries. Yeah,
Yeah.
I'm really looking forward to what the next
What is the
features are
next
gonna
feature
be.
you would like, Ivana, in the Delta Lake?
Um, I think the Z ordering will be one which is gonna be really nice. I got to use it before, and I think it can bring a lot of extra performance benefits. So it's one of the features that I'm looking forward to.
Awesome,
All
awesome.
right.
So Tiri, one more question around like the features. So there was a feature where we have concurrency controls for reads and writes. Delta makes sure that whenever there are multiple reads and writes, it ensures the mutual exclusion and figures out or decides on the order of the write operations. So there is a feature which we were working on in the Delta 1.2 release. Would you like to add
Yes.
what's going on? Yeah.
Oh man, and I'll confess, I'm actually forgetting the entire list of features that we did. So yes, that is again another usability feature. Oh my God, that is such a big feature. So till now, since the beginning of Delta Lake open source project, we have had the problem that since S3 does not provide the necessary mutual exclusion guarantees, we could not support multi-cluster writes on S3. So at any point of time, multiple say EMR clusters cannot write to the same S3 delta table on S3 without breaking uh, while satisfying the ACID guarantees. Finally, we have a solution, and this was a huge collaborative effort between us folks and folks from Samba TV who conceptualized that idea first. We co-designed it together to make it more rock solid, and then finally they developed it, and now it is in Delta 1.2. Is um, true S3 multi-cluster write support using DynamoDB as the mutual exclusion solution. So basically, the crux of the matter is that for ACID guarantees to work, you need to write to the Delta log, basically create a log file into the Delta log directory atomically and mutually exclusively. That is, only one writer should be able to create that log file for version 5. S3 did not provide any API to get that mutual exclusion. So both writers attempting to write 5.json in the log directory would have succeeded, which means that you are overwriting each other's changes, effectively losing data. With DynamoDB, this solution, instead of writing directly to S3, we will be writing to DynamoDB using DynamoDB's mutual exclusion, so that only one of the writers can write to 5, the version 5 to DynamoDB, and then only one of the writer wins. The other one backs off, retries as to write 6, and then all of them work. And then from DynamoDB, we sync lazily. Once the serialized order of the commits have been decided by committing to DynamoDB, we sync it back into S3 so that all writers can now get the full correct view just by looking at the S3 as well. So so that means that any writers, as long they are correctly configured to use DynamoDB, will get the full ACID guarantee properties without chances of data loss. So this is an experimental feature. We released it for the first time. Please look up the details to the release notes and the docs to understand how to configure this correctly so that you are not accidentally uh, writing to S3 without using DynamoDB from multiple clusters.
That's helpful, TD. So I have one question related to that, which was like so you said because of DynamoDB, we were able to get this feature for S3 multi-cluster writes. When you were deciding like how to go about, making sure that we achieve this feature, why did you use DynamoDB? Was this something that Samba TV was already using? So a little bit about, yeah.
That's a good question. So conceptually speaking, any data storage, any database or key value storage store that provides this single row mutual exclusion guarantee, which pretty much all key value stores and databases provide, can be used in this way. We chose DynamoDB because this is primarily a problem only with S3, and so therefore most of the users would be in the AWS ecosystem who are trying to write to S3. So the most natural product in AWS to use seems like the key value store, which very little to maintain, no infrastructure to maintain, just create a DynamoDB table, and you don't need to give it a lot of uh, get put requests per second, like a lot of quota, because this is only for reads writes to at per version. So it's not like it only contains metadata, not data. So it seemed the right natural thing for all the AWS Delta users stuff. So that's why we chose that. But in the future, if other use cases arise where we want to provide multi-cluster write on file systems, need not be S3, but other file systems in the same pattern, file system that does not provide those guarantees out of the box, we could follow the same approach on using other key value stores or databases and stuff, the same technique.
Got it. Okay, that's helpful to know and learn, TD. Yeah, there are a lot of people who might be using other, other type of design considerations. So if you do, please reach out to us either on GitHub or Slack channel, and we can look at those requests as well.
Yep.
So I think talking about ecosystem, there was a feature which community has been excited about, which was in the lines of streaming, which is Flink Sync connector. So any light on how that feature is going, and now since it's available, any light on that would be helpful, TD.
Yeah. I mean, that itself takes a dedicated office hour for that, because we're so excited about that. Like, so much things happened in the last month. We released Presto Trino, we released Flink, we released Delta 1.2. It's very exciting times for us. So yes, we finally have a Flink Sync with which you can write to Delta tables from Flink, both from a streaming job or a batch job. Unfortunately, it is using the Flink Sync Stream API, which is a lower level API. So it doesn't support SQL and table API yet. We are working towards that. That is in progress. But for people who want to start using Delta table on the Flink ecosystem, this is a great unblocking feature. And you can always define Flink. We designed it such the way that it supports Flink 1.12, which is one of the lowest, a pretty old Flink version, and the connector will work on 1.13 and 1.14 as well. You can write streaming queries using table API, but there is a way in Flink to use to get it down to the stream API and use the stream API sync as well. So I think a lot of things is unblocked by this. In parallel, we're currently working on the Flink source, which will have both for streaming as well as batch queries, and also the SQL table API support, so that you can define Delta tables in the meta store and run SQL queries on that purely using Flink. So lots of things in progress. And so, that's the short answer here.
Yeah, so TD, we talked about a lot of features, and there are a lot of features we haven't been able to talk in this half an hour session. So looks like we are done, right? Like we released so many features, and now we are done, right?
and there's a lot in progress. I think some of the features that our next release should have, we're trying to make it happen, is optimize the order. I already talked about that. Then there is another feature we have had in the Databricks version. We were doing a trial run of that, and now we are finally, it's robust that we can safely open source it, is change data feed, where the idea is that if you have DML queries like insert, like update, delete, merge, writing into a Delta table, you Delta table right now uses copy on write to rewrite entire files. So it is harder to read, identify and read only the changed rows that were changed by the delete, update, merge queries, which change data feed that exposes the change, only the changed rows for both batch and streaming reads. So there is another thing that we're very excited about is uh, that's this change data feed feature, and what this will help is build end-to-end in purely fully incremental pipelines, so that if you, one way to think of pipelines is like having this medallion architecture, bronze table, silver table, gold table. You can have fully end-to-end incremental pipelines that append to a bronze table. From bronze, it, let's say, merges changes to the silver table, and from silver it can take the change, only the changed rows, and merge it further into the gold table and stuff like that. Earlier it was not possible to do that efficiently because row level changes were not exposed as a first class citizen.
Yeah, that's exciting, TD. I know we are always working hard, and our community has given us a huge amount of support so that we can make these features happen. And every time their feedback helps us to improve our roadmap. So we are never done, and we keep
Yes,
releasing the features. Yeah,
yes, we are
that's
never
awesome.
done. And just to highlight one more thing, please engage with us on GitHub, on the roadmap posted on the GitHub. That really helps us decide and prioritize what features we want to publish. Like, for example, all of these features that we open sourced uh, was the result of all the feedback we got from the community, from actual practitioners like Ivana here. So this is the culmination of all that feedback that the community has given us. So please continue providing that feedback so that we can keep prioritizing and pushing things out and make everyone's life easier, nicer, and stuff.
Yeah, that's awesome. Thank you, TD. Ivana, since you're already here, before we close out, any feature you would like to request or want to see in the roadmap?
Actually, the change data feed is something that I've already tried, and it's really nice to create incremental pipelines. It's really nice to see that that's coming. That's coming next. I didn't know
It
that.
is coming.
It's really exciting. Yeah, I've used it. It makes your life easier indeed when you're dealing with incremental data. You don't, yeah, all of the updates and inserts that you get, you don't have to propagate all the rows or all the files that were changed to your next job. So that's indeed very nice to hear. I'm excited for that.
Thank
That's
you.
awesome.
This is
Yeah.
very strong recommendation, very strong feedback. So good, we're working on the right set of things.
Yeah, it's always helpful to hear from users, like, some kind of, testament of what the work that community is doing. So it was great having both of you here on the call today. And, for the community, if you would like to get involved in any of these projects, or even if you have feedback, please share with us on Slack, GitHub, or Google Group, and our team works like, not our team, our community works on Slack, and they will be there to answer your questions. So hopefully these sessions are meaningful to you, and we'll see you again next week. Yeah, thank you all.
Thank you very much, everyone. Thank you
Thank
very much,
you.
Ivana.
Bye.
Thank
Thank
you.
you, Vini, for organizing
Yeah,
this. Bye.
thank you.